Welcome. In this video I'm going to show you how you can perform a one-sample z-test using Python. I'm using Jupyter Lab together with Python version 3.818. This is a test that's usually done with larger sample sizes to test for a specific mean. For smaller sample sizes, a student t-test is usually used. I have a separate video on that. The example I'll be using is from the general social survey data. So I'll import pandas so I can use their read CSV function to load the general social survey 2012 data adjusted for example purposes. Now, I don't actually need all the data, I just need one numeric field. So if you look at all the data, there's for example the age field, which has a lot of numbers, but there are missing values, so I'll use the drop NA. There is an 89 or older category, which I'll just then replace with 89, oops, and then make sure everything is numeric. So all of that's done over here, fairly straightforward, and I'll store everything under scale field. As a hypothesized mean, I'm going to be checking if the average age might be 50. Now I have a separate video where I show you how this can be done with my own library, which just has a function to do it. But there are others who, for example, stats models, who've done also a function. So the z-test, for example, from the stats models, once imported, you can actually feed it the data and get the mu. It doesn't really specify what's what, but this is the z statistic and this is the corresponding p-value. Two-sided. So this means that the chances of having a mean in the population of 50 is extremely low. So most likely it's not. So therefore we have a significant result and the average will most likely not be 50. The bioinfo kit has also a z-test. You can initialize it and then you can use the z-test. It does require a data frame, so you can simply convert it to a data frame using pandas data frame function. Specify the x value, which in my case is age, mu, and as a standard deviation I'm just going to use the sample version. I then print out the results with the summary and we get slightly more information and also what's what, sample size, the average from the sample, the z value, and here you see that same result, and as an additional bonus we also get a 95% confidence interval. If you don't want to use any libraries, this is the formula for the z statistic, where this means the sample mean, this is the mean according to the null hypothesis, so my mu, and this is standard error, which in turn is the population standard deviation, but most often it's actually approximated by using the sample standard deviation divided by the square root of n. So we can use for this sample mean simply the mean function from this Python's own statistics library. The standard deviation is available also as a function. The sample size is available as len, so we actually have everything we need. So once I've loaded mean and standard deviation, I actually don't need to do this one. What we'll do is we take the sample size, which is the len of the scale field, the sample mean, perhaps I should call this sample mean. Sample mean is simply the mean of the data. The standard error is the standard deviation of the data divided over the square root of n, which is the same as raising it to the power of a half. And then the z value is the sample mean minus the hypothesized one divided by the standard error. The standard error is the 0.39, etc. And the z value is minus 4.53. We could actually calculate that directly with using SciPy that also has a function for standard error. The p-value can then be obtained by using the standard normal distribution. That's available in the statistics library again, normal dist. And we need a cumulative distribution function, so CDF. And since we're interested in two-sided, we actually multiply the results by 2. So I'll subtract from the absolute value of the z value the cumulative distribution function, 1 minus, and then multiplied by 2, and that gives hopefully, oh, I didn't load the library, the function. So, and that gives the same result as we saw a few times. All right, I hope this video was helpful and thank you for watching.